So you are welcome back to my YouTube channel, and in this video I'm advancing a little bit more into integration. I'm advancing a little bit more into integration. Now I'm going to be talking about integration by partial fraction. That is when we need to use partial fraction in integration. So when we need to use partial fraction integration, imagine we are given a question of something like find the integral of 7x plus 2 all over x plus 3 times x plus 2. In a place like this, then we put our dx. They ask us to look for the integral of this. We cannot just start picking. There is no way that we are going to be able to solve this without using partial fraction first. So first of all, we have to solve for the partial fraction of what is here, right here, before we can proceed to integrate. So picking this out in partial fraction, we are going to divide it as 7x plus 2 all over x plus 3, then x plus 2. It will give us a all over x plus 3, then plus b over x plus 2. These are the values that it is and when we do the partial fraction. So using partial fraction method, I think the first one we are going to get as 7x plus 2 equals to a open bracket x plus 2, then plus b open bracket x plus 3. What we did here is we cross multiply the value, like we find for the LCM. So the LCM of this place and this place, once they become the same, we cancel the LCM each other, we cancel the LCM out. But once we have already found for the LCM, this one comes here, this one comes here. That is what we did here, as simple as that. So then for to get the value of a, now using partial fraction here, to get the value of a, b here has to be equals to 0. That means this whole place here must be equals to 0. So the only value we can actually manipulate here is the integer x. So which value can we use for x here that will make this whole place become 0? When we think about it well, it's minus 3, because minus 3 plus 3 is equal to 0, then 0 times b is equal to 0. So we have gotten what we want there. So in order to get a, b must be equals to 0. B must be equals to 0. Therefore x is equals to minus 3. So when we input our minus 3 in the whole equation, we have 7 times minus 3 then plus 2 is equals to a open bracket minus 3 plus 2 plus b open bracket minus 3 plus 3. We simplify the 7 times minus 3, you have minus 21 plus 2 is equals to, we have minus 3 plus 2 minus 1. So we have minus 1 times a minus a, then plus minus 3 times 3 minus 3 plus 3 0, 0 times b, we have 0. So this is out. Our everything here is going to give us 0. So we have achieved our mission of making b 0. Now we can get the value of a easily here. Therefore minus a is equals to minus 21 plus 2, and minus 21 plus 2 is equals to what? Minus 19. Minus 19 is equals to minus a. Divide both sides by minus 1. Minus 1 cancel the minus here, minus 1 cancel the minus here. Therefore a is equals to 19. Our a here is equals to 19. So now to get for the value of b, we have to make a equals to 0. Let me clear some spaces. So to get b, a will be equals to 0. And for a to be equals to 0, don't forget that the let me write the equation now. The equation is a x plus 2, then plus b x plus 3, which was the main equation here before I cleaned it. So in order to get make a equals to 0, this x here, this whole place here must be equal to 0, not so that b would be able to stand alone. And for this to be equal to 0, which value can we make x that will make this whole place 0? That is -2, because -2 plus 2 is equals to 0. 0 times a is equals to 0. So we have known that our value for x will be equals to -2. So if a will be equals to 0, therefore x is equals to -2. X is equals to -2. So then we put it into our equation. We have 7 times -2 plus 2 is equals to a open bracket -2 plus 2, then plus b open bracket -2 plus 3. So doing the 7 times -2, we have -14, then plus 2 is equals to -2 times 2, 0, 0 times a, that is 0, 0 plus b -2 times 3, -2 plus 3, that is 1, that is 3 minus 2, same thing as -2 plus 3. So 3 minus 2, that is 1, 1 times b is b. So therefore our -14 plus 2 will be equals to -12. So -12 is equals to b. So here now we have our a is equals to 19 and our b is equals to -12, which is the first step before we go back to our integration. So now the equation here was broken down into a over x plus 3, then plus b over x plus 2. So we have gotten our value for a. A is equals to 19 over x plus 3, then plus our b is equals to -12 time over x plus 2, which is going to give us 19, which is going to lead to the integral here. We are bringing back our integral again. So we have our integral of, in brackets, 19 over x plus 3, then -12. The minus times plus here will be -12 over x plus 2 dx. Now, to solve this again, we are going to be using the method at which I used in my former video, which is solving of linear functions, function of a function. So right here, let's just break it down into two parts because of the subtraction sign. So now this is the same thing as integral of 19 over x plus 3 minus the integral of 12 over x plus 2. This is the exact same thing. So right now, in order to solve this, we'll make the bottom one into u. We'll make the bottom one become u. So we have x plus 3 here. U will be equals to x plus 3 here. X plus 3, that means du dx is equals to, differentiate this one, du is equals to dx for this part. So we know here that our du is equals to dx when we are solving. We also have a dx here and a dx here. A dx and a dx here. So our du here is equals to dx, and for this other place, du is equals to x plus 2, x plus 2. So du dx is equals to 1. That means du is equals to dx. So in this other place too, du is equals to dx. So we already have a common value there. So when integrating this, we are going to put this as, let's say, u1 and this one as u2 something, so that we do not misplace the letters. So we have our u1 equals to x plus 3, u2 is equals to this. We will end up getting integral of 19 over u, but our dx is the same thing as du. Our dx is the same thing as du, so we have du because our dx is equals to du. Then minus another integral 12 over x our x plus 2 here, this is u1, our x plus 2 here is equals to u2, then the u, let's say the u2, the u1, so that we can be able to know that we are mentioning this for this and this one is for this. Um, that's what I'm trying to expatiate. So now, integrating of this, 19 is a constant, so 19 can come outside, but integrating of this, we have 19 integral du1 over u1 minus 12 integral du2 over u2, because 12 is a constant and 19 is a constant, so we can bring it outside the integral sign. So now, what is du over u? According to integration, du over u, that is the integration, du over u is equals to in u. That is the straight formula, it's like a constant. So directly here, we know that NID is equals to 19 in u1 minus 12 in u2. So this is our answer, but we have not added our plus, our constant, and we are going to be bringing back our u1 and our u2. Right now, we are just going to be putting this into, we are going to be putting the value of u1 and u2. So we have it as 19 in u1, but that u1 now, we're not writing as u1, we're writing it as u1 was x plus 3, so that is in x plus 3. Then we go minus 12 in u2. u2 is equals to x plus 2, we are bringing it back, x plus 2. Then we add our plus c. Always remember to put your plus c after solving any integral equation. Always remember to put it. So now let us go through a little bit summary of what we did here. First of all, we solved what was in the box. We solved the equation. We used partial fraction to break it down into its different parts. There are questions whereby instead of them to give you the square root, they will just give you the whole quadratic equation. You would look for the square root and try to be solving it after getting the square root before you start using partial fraction. But here is straightforward. You already know directly that you are using partial fraction. We break it down into a and b. We got our value for a and b. Then after getting them, we already have two different equations, so we solve them differently. We integrated them differently here, and after integrating them, we got our answer with its constant. So that is how we got the answer.